Most people solve this problem using nested loops, but there's a much faster way to do it. In this video, I'll show you the brute force approach and then optimize it using a hash set. This is day 6 of my DSA Growth Series. So in this problem, you are given an integer array called nums. Your task is to determine whether the array contains any duplicate elements. If any value appears twice, at least twice, return true. Otherwise, return false. So we have an example also here. Nums array, the values are 1, 2, 3, 1. So as we can see, 1 is repeated twice. So the output will be true. And in example 2, there is 1, 2, 3, 4. And as we can see, no element is getting repeated twice. So the output will be false. That is, all the elements are distinct. So let us discuss about the brute force approach on this problem. So the brute force approach is to compare every element with every other element. We use two loops. For each element, check if the same element appears again. So code idea would be around like we have an outer loop of I and an inner loop of j, where we check if nums of I double equal to nums of j and return true. So since two loops, nested loops, are being used here, so the complexity would be O of n square. So this becomes very slow for large arrays. Uh, so instead of comparing every pair, we can track elements we have already seen. So this is where the hash set helps. Hash set stores unique elements only. So if we try to insert a number that already exists, we know it's a duplicate. So yeah, algorithm somewhat would be around. So we'll create a hash set and we'll iterate through the loop, we'll iterate through the array, and in each instance we'll try to add the element to the set. If that add method returns a false there, so we know that uh, there is a duplicate element, so we can directly return the value there. Otherwise, once the loop gets finished, we can return false. So we can start the code of implementation now. So at first, as we told, we'll use a set, and this will be a set of integer. What to name it? Let's name it single. This will be a new hash set. Now we'll iterate through the array for int a, and our array name is nums. So here we'll try to add the element to the array. So add method in set basically returns a boolean flag. If it is able to add, it returns true. If it is not able to add, it returns false. So we'll try to add here. And if it is not returning true, then we'll return true here. That means we have found a duplicate array, duplicate integer. And since like if we don't find any duplicate integer, so this return statement will not be executed at any time. So we'll come out of the loop, and which means we haven't found any duplicate number. So we need to return false here. And yeah, so simply saying, we iterate through the array, we try to add a number. If that method returns a false there, we return our answer. That means we have got an duplicate number. So as we can see, we iterate through the loop only once. So time complexity for an integer of size n would be O of n, and space complexity is also O of n. So yeah, now we can just try to run this. Yeah, as you can see, all the cases are being passed here. We'll submit. So yes, our solution beats 99.43. Yeah, so that's the optimal solution for this program. Yeah, so if you found this helpful, subscribe for daily DSA growth. See you in the next problem. Thank you.